Okay, so I think if you can note, I think the audio is a bit, maybe a tiny bit better now. So let's see. So question 9, right? This is well, there's no circle here, which is fine. It's not, it doesn't necessarily make it anything special, but fine. It says in the diagram, right? D, E, F, G. So there's D, E, F, and G. It's a quadrilateral. Now, as we can see, they told us that this is 45, this is 80, and then they say there are diagonals that meet at H, right? There's DA, DF, and GE, they meet at H. And then it says here, this angle is equal to that one. So they've labeled what's equal here. This angle here is, they said here, GDE, GDE is equal to FEG. So let's put those in pink. This is equal to that, okay. And then in blue, they said here DGE, which is this angle here, it is equal to EFG up there. So this is like over there. Perfect. Now, with this being said, right, let's see what these questions are. The first question is asking us, it's a 1-mark question. They're asking us for a reason why DEG. So let's actually highlight what DEG is. So DEG, there's like DEG there. So it's like this. Let me see here. It's like this, right? And then this. And then this. So this is DEG. And then the other triangle we're talking about is EGF. So there's like EGF, right? So it's like over there and over there. So the moment we have highlighted these two triangles, it becomes clear to us why this is a 1-mark question. So from your perspective, why would you say these two triangles are similar? If you were to answer this question.
I'm not really sure.
Okay, so the fortunate thing is when it comes to similarity, right? Yeah. There's one way to prove similarity. The one way to prove similarity is to show that all three angles of all three angles of one triangle are equal to all three angles of the other triangle. That's how you prove similarity. So in this case, if you look nicely, our purple triangle here and our orange triangle down here, there's a pink angle here that is equal to the pink one there. There's a blue one here that is equal to the blue one there. Automatically, if two pairs of angles are equal to each other, the third ones are automatically going to be equal to each other because of the sum of interior angles of a triangle. You see, meaning if you take 180 and you remove these two, and you take 180 and you remove these two, whatever is going to be left is the same value. So for 1 mark here, they said give a reason why these are similar. So because they already told us that these two are equal to each other, right? And these two are equal to each other. All we can say is angle EGF is equal to DEG. The reason is sum of interior angles of a triangle. You see, that's the reason. That's the reason why those two, those two angles are equal. It's because of the sum of interior angles of a triangle. The other two pairs being equal, they gave that to us, you see. So we're just carrying on from what has been given, meaning that the last thing we can then say is therefore triangle DEG is similar to triangle EGF. The reason is just angle. You see, all three angles are equal to each other. That's going to be enough for that 1 mark that they're offering there. Does that make sense?
Yeah.
Perfect. So the other 9 marks in this question, right? It is definitely a situation where we're going to have to make use of what we have gotten from 9.1. Because with 9.1, what we basically got there is similarity, triangles being similar to each other. So it says here, calculate the length of GE. But before we can worry about calculating the length of GE, the one thing I can say is, if you have proven similarity, right, as long as your letters here are corresponding, meaning that the D in this triangle, let's see here, there is DEG, right? And there's EGF. So the angle D in this triangle is equal to the E in this triangle. That's what we should see. But let's just look at it again. DEG, and then you have EGF. Yeah. So what that means is, you see the D in this triangle here is equal to the E in the other triangle. That's why here you can see there's the pink angle there, and there's a pink angle for the other one. You see, if you look some more, the E portion of the one triangle is equal to the G of the other triangle. And then lastly, the G of this triangle is equal to the F of this triangle. That's why there's a G here, and that's why there's an F there. Do you see how these are aligned with each other?
Yeah.
So when you name your triangles, right, you need to make sure that that's the case. These need to be aligned. There's very, very rare cases where they're not aligned. I think just last week I was going through a Northwest paper. It's the first time I'd actually seen these were mixed around. So the reason I'm mentioning this is, as long as these are like aligned nicely, you are able to write out different expressions, and we'll use those expressions just now. Here they're asking for the length of GE. GE is this distance here. Before we can worry about getting GE, just from the top of our heads and all that stuff, what all we need to figure out is that with GE, right, before you can worry about getting GE, as long as two triangles are similar, you are always able to write out expressions that can help you work out different lengths in your sketch. So what I mean is, as long as triangle DEG, DEG is similar to triangle EGF, as long as this is happening, what we can write out is DE over EG, DE over EG is equal to EG over GF. So you have here EG over GF, which is also equal to DG over EF. DG over EF. You're able to write it out, write all this out. Your reason will just be proportionality theorem. Now, the reason for you writing this out is because of the question they asked, right? They asked us to get EG. Now, the issue with EG is that, fortunately, when you've written all this out, right, you can just look out for where EG is. And here is EG. So you know that, okay, we have to make use of this specific ratio, because all three, you cannot use them all at the same time. You have to use two at a time. Either this with this, or this with this, or these two together. It doesn't matter. So what we already know is we're going to have to make use of this, you see, because we need EG. So in our sketch, if you look nicely, we need EG, right? Fine. But then if you look at what we have here, you want to look for what of these do you have? So do we have GF? Let's go look at our sketch. The GF, yes, we do. You see, and it's kind of obvious because they'll always set up a question according to what they've given you. So the GF is given, perfect. What else is given? There's DE. So we might as well go with this option. What else is given? Nothing. We have EG missing here, or rather, let's look where EG is. EG, we don't have EG, so EG is missing. So fortunately, I mean, like, there's EG missing, it's still the same thing, so it's fine. It looks as though these two are what we can use to answer our question. So in the next line where the DE is, we can just drop the 45. It's going to be like 45. EG is what's missing. EG is what's missing. And then here we have GF, which is 80. So there's 80 here. So with this being done, or with all this being said, we can now like cross multiply, right, to work out EG. Cross multiplying again, I have EG squared here. In our calculator, let's see what we can have there. Let me just grab this calculator. because it's definitely not next to me. Why? I don't know. But let me just
So
grab this calculator quickly. Let's see, 80 times the 45, we're getting 3,600. So EG squared is equal to 3,600. Perfect. Now, from what we have here, we can just square root both sides. So we can
Yeah.
square it here, square it here. This is like EG, right? Square root of 3,600.
60.
It's going to give us a 60. Yes, it's going to give us a 60. 60. Perfect. Now you can see if you compare it to the other lengths, it's kind of fitting there. You know, EG being 60, it kind of matches. You know, 80, 60, 45. It's in the zone. So we are certain of our answer. We don't have to, like, you know, think it's wrong or anything. So let's just look at the next question. Just do this. So with the